Today, people, I am going to continue the application of derivative part, right? So, application of derivative part is very important part, right? Yeah, write down the heading there as application of derivatives. Application of derivatives, right? Write the heading as application of derivatives. Okay, people, now before going to this part, we must discuss something about the straight lines, right? Some theories under the straight lines we must discuss, right? Yeah, the straight line lesson, we will discuss this again, but at the moment to do the questions in differentiation, application of derivatives, we must learn little important theories under this straight line. Write down, people, the subheading as straight line. Right. Now, we define the straight line, the standard equation of the straight line, people, like this: y equals mx plus c. Okay. So when we draw the straight line here, suppose this is the straight line on the xy Cartesian coordinate plane. This is O origin. This is that line. Okay. So now suppose this line is L. Right? Line is L. This line makes angle here. This angle, if I take as theta, this angle is measured in anti-clockwise sense. That is what this arrowhead shows. That is measured starting from positive x-axis. Here is a positive x-axis. Starting from the positive x-axis direction, the angle measured in anti-clockwise. This angle is theta. For this angle theta, we can find its tan value. We can find its tan value, tan theta. That tan theta only, people, we define as the gradient of this straight line. Here the m is called as the gradient, right? And this c is called as the intercept. Intercept. This intercept is defined to be the line this cuts the y-axis somewhere here. To this point, there is a height from the origin. This height is called as the intercept. Understand? Okay. So then gradient is the tan theta. Then when you take this gradient, people, the angle you must take is very important. The angle should be with the positive x-axis measured in anticlockwise until this line. What's the angle? That is the one we take as theta. Its tan value is the gradient of the line M. Okay. Now you can see very clearly when this angle is acute angle, right? When theta is acute, acute means less than 90, greater than 0. For acute angle, that angle lies in the first quadrant, first quadrant, like this. In the first quadrant only, people, angles which lie between 0 and 90 available, right? Then when theta is in between 0 and 90, angle is in the first quadrant. For the first quadrant angles, people, we learned in the trigonometry lesson, tan, sine, cos, all three are positive. Tan positive. So therefore, tan theta positive. Tan theta positive, greater than 0 means positive, but tan theta is M. M is positive. Therefore, when the angle theta is in between 0 and 90, the gradient of line is, people, positive. Now, sometimes, people, this angle of the line may be obtuse angle like this here, this way, and maybe obtuse angle like this here. Okay. Now, in this case also, the gradient of this line is given by the tan of this angle. Gradient is tan theta. Here also, look at this angle. This is the positive x direction. From there, we measure the angle in anticlockwise until the line. This time, this angle is obtuse angle, more than 90. When the angle is obtuse, people, tan theta is negative. So therefore, this time, when theta less than pi, greater than pi by 2. What is this? Theta greater than 90. Okay, greater than 90, less than 180. That occasion, tan theta is negative. In the second quadrant, no. Angle in second quadrant angles, we know people. In the second quadrant angles, tan is negative. Right. We learned that in trigonometry lesson, right? So then we get tan theta negative. Tan theta means the gradient negative. So therefore, you can very clearly understand, right? Straight lines with positive gradient will make acute angle here. Straight lines with negative gradient will make obtuse angle here. That too you have to first understand. Okay, right. Secondly, people, let's see what is the meaning of this equation of the line. The equation of the line mean, people, you can very clearly understand when I consider any point on this line, there are infinitely many points on the line. When we consider any point on the line, this point has x coordinate and y coordinate both. This is the x coordinate of the point this. This is the y coordinate of the point this. People, that we mark like this, no? X, y. Right. Like this, when we consider any point on the line, that point has two coordinates, x and y. Now, the equation of this line mean, people, the general relationship between x and y. The general relationship between x and y is called as the equation of the straight line. Now, for example, if I consider equation of a straight line like this, y equals 2x plus 1, okay, let's see what is the meaning of this equation. This straight line, when we, of course, consider, suppose the line is like this, x here, y here, the intercept is 1. Take any point on the line as coordinates x, y. Then the equation means, people, any point on the line, when you consider there are two coordinates, its y coordinate of any point is always equal to multiplying its x coordinate by 2, add in 1. Understand? When you consider any point, it has two coordinates. The y coordinate of that point is always equal to multiplying its x coordinate by 2 and adding 1. This relationship between x and y is true for every point on the line this. That is the meaning of this equation of the line. Understand? So now I think you have an idea about what is meant by the equation of a straight line. Right. Now, the next thing you must understand in this case is, people, the meaning of the gradient. The meaning of the gradient. Okay? The meaning of the gradient. The meaning of the gradient, if I, people, explain, we can explain it in this way. Now, I'll take this way our line. Right? This is the y-axis. This is the x-axis. This is O. Right? The gradient we define like this. If this angle is theta, gradient is defined to be tan theta. No? Right. Now I am going to construct somewhere here a right angle triangle. This side is parallel to y-axis. This side is parallel to x-axis. If this angle is theta, this is also theta. This is right angle. Right. So now I drop a perpendicular from here to the x-axis like this. Another perpendicular here. to x-axis like this. And on the y-axis as well, I draw perpendiculars like this. Right? Then you can write tan theta by using this triangle. That means opposite side this divided by adjacent side this is the tan theta. People, when I write tan theta here, let us take this point as A, B, and this as C. Then tan theta, you can write the opposite side BC divided by the adjacent side AB. This way we can write. Let's see what is this BC. But let's see what is this AB. People, AB means what? AB means the distance from here to here. So when we move from here to here, you can see the increment of x we have here. When we move from here to here, increment of x here we have. Okay? Or else, in other words, change of x. Right. Now, people, when we move from here to here along the x-axis this way, when we were here, the y value is this. And when we were here, people, y value is this. Then this BC means, people, when we move from here to here, right, the increment of y is this BC. That means change of y. Understand? Change of y. Right? If I use the word change of y, that's correct. The reason, when we were here, y is this height. And when we come to this point, y is this height. Then our y value increase from here to here. Our y value increase from this level to this level. Right? Increase of y. That means change of y. This AB means change of x. People, then I can write this one as change of y. AB means change of x. Tan theta means the gradient. So therefore, gradient is equal to change of y divided by change of x. Understood? Right. Now suppose this change of x is 2 units. The corresponding change of y is suppose 3 units. That means BC is 3, this AB is 2. Then if I apply here, 3, change of y, change of x is 2. This is a gradient. When I further simplify this, people, I can write 3 divided by 2 is 1.5 divided by now 1. Right? We get 3 divided by 1.5, no? 1.5 means 1.5 divided by 1. That's what we have. People, now this is the gradient now. So how do you interpret this gradient? Now this gradient you can interpret as how, people, we notice this denominator means change of x. Now it is 1. This means change of y, corresponding change of y. It is 1.5. What do you mean by this, people? When x changes by 1 unit, the corresponding change of y is the gradient. Understood? When here denominator is the change of x. Now it is 1. When the change of x is 1 unit, the corresponding change of y only the gradient. Understand? So therefore, think like this. People, now suppose like this. A particle moves 10 meters in 2 seconds. A particle moves 10 meters in 2 seconds. Displacement is 10 meters. Time taken is 2 seconds. Then, people, how to find the number of meters the particle moved in 1 second? This 10 divided by 2, no? This is measured in meters. This is measured in seconds. This is 5 meters per second. What do you mean by this? In 1 second, number of meters moved by the particle. People, that is known as what? That's called as rate, no? Rate of change of displacement. Rate of change of displacement. So therefore, people, when we have a fraction, the numerator and denominator both vary. Suppose here also displacement, time, right? This fraction, when we consider, we get 10 by 2. Numerator displacement, denominator time. When you simplify this, we get 5. Now, in this case, under this 5, we have one denominator. People, in this case, when the denominator is 1, that occasion, this fraction is called as, people, rate of change. Rate of change. If we use the word rate of change. Rate of change means, people, something takes the form of a fraction. When its denominator changes by 1 unit, the corresponding change in numerator is called as the rate of change. Here also, people, the same thing is true here. Then gradient means what? Rate of change of y relative to x. See the words I used? Rate of change of y relative to x. What do you mean by that? Relative to x means, people, when x changes by 1 unit, the corresponding change in numerator y is called as the gradient. That is called as the rate of change of y relative to x. Understood? Now, for example, when I take, people, v as the velocity, t as the time, right? Then what is v divided by t? Rate of change of velocity relative to time. What is that? In 1 second, right? Change of velocity. People, what is that? It is called as the acceleration. If this velocity increases, then it is an acceleration. If this velocity changes by decreasing, it is retardation. Understand? So therefore, rate means that. If we consider another example, suppose a child can eat 500 grams of rice in 10 seconds. Suppose a child can eat 500 grams of rice in 10 seconds. So now we need to find the rate of eating what rice? Rate of eating rice means what, people? In 1 second, number of grams of rice this child can eat. That can be found dividing this 500 by what? 10. Right? So we get what? This way. 50 grams per second. Understood? Then their rate means, people, in 1 second, the weight of rice the child can eat. So therefore, people, if anything takes the form of fraction, numerator and denominator, while both are varying, then once the denominator changes by 1 unit, the corresponding change of the numerator is called as the rate. Then here, people, the gradient also, what? Gradient also rate of change of y relative to x or with respect to x. That means if x changes by 1 unit, the corresponding change in y is called as what? Rate of change of y with respect to x. That is the gradient. Right, that is the meaning. Right. People, now, when I consider this thing again, now you know, people, gradient stands for rate of change. M is the gradient of this line. Rate of change of y relative to x or with respect to x, right? With respect to x. This with respect to x means we can use the relative to x. Relative to x, right? Sometimes it's with respect to sentence we abbreviate w dot r dot t like this, with respect to. Okay, right. Now suppose, people, this equation of the line I'll take as y equals mx plus c. I'll take that as y equals mx plus c. Now what I am going to do, I am going to differentiate these, people. What? This y equals mx plus c line, I am going to differentiate with respect to x. Y equals mx plus c. Here this m and c are, people, two constants. Now you know, you have learned differentiation. So we can differentiate this with respect to x. What is that? Dy by dx equals m is a constant. Constant means a real number, no m. C also real number. Then we have to keep this m as the same. Derivative of x with respect to x is 1. This constant c is alone, therefore derivative is 0. Understood? Then we get people dy by dx is equal to m. See here. Then really by the derivative dy by dx, what we really get, people? We get gradient. We get the gradient. So far, in many places we obtain dy by dx. Then people, really, what have we found? We have found, people, the gradient of that given graph. The gradient function of the given graph only we found by finding this dy by dx. Therefore, the practical meaning of, or the geometrical meaning of dy by dx mean, people, dy by dx gives us what? The gradient function of a given curve. Right? But we know the gradient means what? Rate of change of y with respect to x. So therefore, this dy by dx also, since it is equal to what? Since it is equal to this gradient, dy by dx is equal to what? Rate of change of y with respect to x. Understand? So therefore, people, for instance, if I consider here, x is the displacement. X is the displacement, right? Right? T is the time. V is the velocity. Right? Let's take like this. Then what can you say about dx by dt? Rate of change of displacement relative to time. Okay, what is that? Dx by dt is, people, now velocity. This is velocity. Number one. Secondly, dv by dt. V is the velocity. Rate of change of velocity relative to time. Rate of change of velocity relative to time means, people, what? In 1 second, change of velocity. What is that? Acceleration, no retardation. If this velocity changes so that it increases, then it is an acceleration. If this velocity changes in the decreasing direction, people, the dv by dt is retardation. So therefore, this is either acceleration or retardation. Understand? People, now this is the important part in the lesson. Dy by dx gives us the gradient. The gradient means rate of change of y with respect to x. It means when x changes by 1 unit, the corresponding change of y is the rate of change of y with respect to x, or the relative to x. Right? Okay, these things, people, we must first understand. The next one is, here we have to understand, people, these things. Right? Now, suppose this theory part we again discuss, where in the straight line lesson. Until then, we have to just know this one to work out some questions in this lesson. That part is this. People, now suppose we have a straight line like this. Its gradient is known. Gradient is given. That means of this angle, tan value is given. That gradient is given. And also, people, we know a point on the line with coordinates. Suppose this coordinates of this point x0, y0. Understood? X0 is a real number, y0 also a real number. Right? Now, people, asking to find the equation of the straight line. Okay? Now, what are the things we are given? Gradient of the line given. And another point on the line also given. Another point means a point has two coordinates, no? X coordinate and y coordinate. That x coordinate and y coordinate both are given. Gradient also of the line given. Now, we are asked to find the equation of the straight line. People, remember, we prove this one in the straight line lesson. Our next lesson is that the equation of the straight line is obtained like this. Y minus the y coordinate of the given point, y naught, equals gradient times x minus x coordinate of the given point. This is how people, we take the equation of the straight line. Understand? Right? This x and y, they represent people what? X and y coordinates of any point, right? Any point when we consider here, x, y are its coordinates. We said the meaning of the equation of a straight line. What people? The meaning of the equation of straight line? When we consider any point on the line with coordinates as x and y, the relationship between x and y is called as equation of the line, no? Then people, that x and y only here we have. That x and y only here we have, right? So therefore, how to write? Y minus y coordinate of the given point equals gradient times x minus x coordinate of the given point is the way of writing the equation of the straight line when we are given the gradient of a line and a point on the line. Understood, right? Okay. Then the other one, people, we should understand in this case. People, suppose like this, we have a straight line on the OXY Cartesian coordinate plane. This theory also we discussed in the straight line lesson, but some questions we will have to discuss, work out in this lesson. Suppose we have a line L1. Suppose its gradient is M1. Suppose we have another line which is parallel to this L1. These two lines are parallel. When these two lines are parallel, people, the line this also has the same gradient as M1. Right? So therefore, remember, parallel lines have the same gradient. That we prove in the future in the straight line lesson. And the other one, people, suppose perpendicular to this line L1, we have another line like this. The L1 line and the line I drew here, suppose L2, these two are perpendicular. When two lines are perpendicular, people, right? There's a relation between the gradients of the two lines. When two lines are perpendicular, right? Like this. If the gradient of this is M1 and this is M2, people, when two lines are perpendicular, product of the gradients is equal to -1. Product of gradient is equal to -1. Understood? Right? This theory also we prove, but we will have to use this one in this lesson. That is why I give you. And the same thing, of course, we can write in another way. Suppose this line gradient M1. Then for this M2, M1 product to be -1, we can very clearly understand, people, when I subject this M2 here, M2 is equal to -1 over M1. So therefore, the gradient of this line going to be -1 upon M1. That means, people, using this gradient of this line, we can obtain the gradient of its perpendicular line. How? This gradient M1, first we take the reciprocal. People, when I write M1, what is that? It is M1 by 1. No? Take reciprocal. Reciprocal means what? 1 upon M1. And multiply by minus sign, like this here. 1 upon M1 multiplied by minus sign. So then we get the gradient of the perpendicular line. So now, for example, suppose we have line, gradient is 2 by 3. How to find the gradient of the perpendicular line? Take the reciprocal of this, 3 by 2, and multiply that by minus sign. Then we get the gradient of the perpendicular line. Understood? So these things we need to work out questions in this lesson. Right, people? Right. Now we shall take down a brief note under this. Thereafter, we can come to the questions in the tutorial. Okay. Any doubt, people? Any question? Please ask if you have. Right. Now we'll take down the nodes. Write down here under the application of derivatives, the first subheading as straight line. The first subheading as straight line. Subheading write down as straight line. Right. Write down like this. Write down the equation of the straight line. The equation of the straight line in gradient within bracket simple lim and intercept C. Form is y equals mx plus c. Y equals mx plus c. Write down this y equals mx plus c. Right. We'll draw this diagram also. Let this angle be theta. This height only people we define as C. This is origin no. Right. Line L. How define the gradient? Right? M is the gradient. C is the intercept. C is the intercept. Okay, right. Now you can write on paper like this one sentence. After drawing this, we'll write one sentence. Write down. Let the line simple L. Let the line simple L makes an angle theta let the line simple L makes an angle theta with positive x-axis in anticlockwise sense. In anticlockwise sense. In anticlockwise sense. Then the gradient of the line, then the gradient of the line is defined as, then the gradient of the line is defined as tan theta. Tan theta. Gradient of line is defined as tan theta. Write down that is m equals tan theta. M equals tan theta. Write down. Next one, next line, write down. The height or depth. The height or depth. The height or depth. The height or depth to the point where the line cuts y-axis. Where the line cuts y-axis. Is defined as the intercept of the line. The intercept of the line. Right. Write down starting from new line. When theta is acute, the gradient of the line, when theta is acute, the gradient of the line is positive, and when theta is obtuse, the gradient of the line is negative. The gradient of the line is negative. Right. Draw two small diagrams, people, like this. Line with positive gradients are this way. Next one. Line with negative gradient. This angle obtuse now. This is acute. This is acute angle. This is obtuse. Okay, no? Right. Right. Now write down, people. Next one, meaning of gradient of a line. Meaning of gradient of a line. Right. Comes that subheading, meaning of gradient of a line. You draw this diagram. This is theta. Gradient is tan theta. M equals tan theta. Gradient is m. I can construct this way a right angle triangle. Okay, this is theta. Then how to write tan theta by using this triangle? This change, this change. This is what? Change in y. This is change in x. Then tan theta means opposite side divided by the adjacent side. Let us take this as A, this point B, this point C. Then we can write M equals AB divided by BC. Then M AB, change in y. Divided by change in x. What is that? When you simplify these people, we get one answer, no? As I illustrated earlier. What is that? Rate of change of y relative to x, right? You can write rate of change of y relative to x. In other words, that is M, rate of change of y relative to x. The same thing we can give people how? In other words, the change of y for the change of x is 1 unit. Or in other words, when x changes by 1 unit, the corresponding change in y is the rate of change of y relative to x. Write down that is, as x changes by 1 unit, as x changes by 1 unit, as x changes by 1 unit, the corresponding change in y, the corresponding change in y is the rate of change of y with respect to x. With respect to x. Right now. Right. We will now come to the next part. Write down next subheading like this. The equation of the line with gradient simple name m and passing through the point x naught comma y naught. Passing the point x naught comma y naught. Right? We will prove this theory, people, in the straight line lesson, right? Until then, straight away take down this one without proof, because we need this theory part to work out questions in this lesson, right? Yeah, we'll draw like this, people. The line, x-axis this, y-axis this is the line. Gradient is m. Any point on the line is x naught, y naught. Okay. This x naught, y naught are two real numbers, right? Two real numbers. Any two real numbers, huh? You know what is meant by real number. Yeah. Then the equation of the line, therefore, the equation of the line is y minus y naught equals gradient times x minus x naught. Right. Right. Draw this diagram and obtain this result. Write down this result. We will come to one example here. Find the equation of the line with gradient minus 2 and pass in through 2 minus 1 and pass in through 2 minus 1 and pass in through 2 minus 1. Gradient is minus 2. We'll apply this one directly, people. Y minus y naught means this y coordinate. Y naught means of the given point y coordinate. It is minus 1. Equals gradient minus 2 x minus 2. Here we get plus 1. Remove the bracket, minus 2x plus 4. Take all the terms this side. 2x takes this side, 1 minus 4 minus 3 equals 0. This is the equation of the line we need. Y plus 2x minus 3 equals 0. Right? Right. You can now come to the next one, people. Write down another subheading: parallel lines and perpendicular lines. parallel lines and perpendicular lines. Write down like this. Number one, parallel lines have the same gradient. The same gradient. Number two, write down, let the lines L1 and L2 be perpendicular. The two lines we have, this is L1, this is L2. Suppose the gradient of this as M1, gradient of this line as M2. I am not going to draw these lines in the OXY Cartesian coordinate plane. There only we draw this one, but I do not draw here XY axis, right? Then the gradient of this is M1, that of M2. The gradient M1 multiplied by M2 product is equal to -1, no? Not +1, -1. Right? M1, M2 product is -1. Or you can write M2, this gradient is -1 upon M1 like this, huh? -1 upon M1. M2 equals -1 over M1. Right. Okay, now we'll come to the next important thing. People, the next important thing, earlier I, of course, forgot to explain that. Another thing we have, that property is this. People, now suppose we have this way a straight line. On the line, there are 2 points. Suppose this point is P, coordinates x1, y1. This point Q, coordinates x2, y2. This theory part also we need to work out questions, but I'll mention that also. Now, there are 2 points on the line P and Q. By using the coordinates of this P and Q, we can find the gradient of the line. The gradient of the line can be found like this. Gradient, suppose M, that is equal to, take the difference of y coordinates, y1 minus y2, and divide that by the difference of the x coordinate of the same order, x1 minus x2. Understood? y1 minus y2 divided by x1 minus x2. This is how we find the gradient of that line. This theory also we sometimes use to work out questions. Right? This theory also we prove people in the straight line lesson. I consider these things to work out some questions. Right? Write down next one. Gradient of the line. Gradient of the line. Gradient of the line. Gradient of the line passing through two given points. Passing through two given points. passing through two given points. Right, draw this diagram and write down the result. M equals difference of y coordinates y1 minus y2 divided by x1 minus x2, right? Right. Now we'll come to the next part. We'll come to a knot. Right. Consider the line y equals mx plus c. Consider the line y equals mx plus c. Now I am going to differentiate this. Y equals mx plus c. We can write differentiate in with respect to x. What do you get? Dy by dx is equal to m is a constant or real number or derivative of x 1, c is a constant 0. Therefore, dy by dx is equal to m. Now dy by dx has all the properties this m gradient has. Dy by dx gives us m, that means dy by dx stands for gradient. Or dy by dx is equal to gradient. What is that? Gradient means what, people? Rate of change of y relative to x. Equal rate of change of y relative to x. Right, people? This statement is the most important one in this case we use. Right, I can write next one. For instance, let x the displacement. X is a displacement. T the time. V the velocity. V the velocity. Then what is dx upon dt? Rate of change of displacement relative to time. What is that? Rate of change of displacement relative to time mean in 1 second number of meters as the displacement moved. That is velocity. Number 2, dv by dt. dv by dt. Rate of change of velocity relative to time. That means in 1 second, change of velocity. In 1 second, change of velocity. In 1 second, increment of velocity or decrease of velocity. If it is moving to the increasing direction, it is acceleration. Otherwise, it is retardation. So therefore, dv by dt is what? Acceleration, no retardation. Acceleration, no retardation. Right. People now will come to some questions. Right. We'll come to some questions. Take the first question. We'll write one example. Right. Right on. Find the equations. Find the equations of the tangent and the perpendicular drawn to the curve y equals x squared plus 6x minus 1 at the point x equals 2. At the point x equals 2. Right? Yeah. Even now, when we consider this graph, you can remember this graph is quadratic graph. X squared term, x term, and constant it has. And x squared coefficient is +1. When the x squared coefficient is +1, you know this graph has minimum shape. Okay. Quadratic graph. I'll just take the graph, not exact correct diagram I am drawing. Suppose the graph is like this, huh? Graph is like this. Okay. Right? Yeah. Rough graph only I drew. Now suppose I'll just take without the axis here. Suppose this minimum graph like this, right? Graph is minimum graph. It's a obvious fact, no? It's a graph, suppose, huh? Now, here we need the x-axis also. All right, we'll take like this x-axis. Suppose y-axis like this. Right. Suppose x equals 1 somewhere here. This is not the correct graph, huh? Correct graph, not anyway important to take these answers. We can draw the correct graph if necessary, huh? Right? No point of draw the correct graph, huh? Yeah, suppose x equals 1 point is here. And then I take that x equals 1 point here. When I draw a vertical line to meet this graph through x equals 1, that point is here. Then this point has the x coordinate 1, this one, right? Here the equation is y equals x squared plus 6x minus 1, right? People, can you tell me, at this point x coordinate is 1, how to find the y coordinate? That x equals 1, we substitute here, and we can simplify that. Understand? Right. First of all, we can write at x equals 1, y. 1 squared plus 6 into 1 minus 1. 1 squared is 1, 1 minus 1, 0, 6 into 1 means 6. Y equals 6, 1, 6 is the point. So this point is, people, 1, 6 now. This point. 1, 6. Right. Yeah. At this point, people, at this point, to this graph, we can draw a tangent. What is meant by a tangent? People, tangent means, you know, in your oils, you have drawn circles. We can draw a straight line to cut this circle at 2 points like this. When we lower this line, what happens, people? The 2 points of intersection come in closer here. Come in closer like this. Like this, when we lower this line, people, one occasion, this line touches this circle with these 2 points of intersection overlap each other. That occasion, we define this line as a tangent to the circle. It is like this now here. Like that, people, for a curve like this, suppose a curve like this, tangent also we define like that. When we draw a line like this, we bring this line downward like this. One occasion, this line will touch the curve at a point. That occasion, the line is called as the tangent drawn to the curve at that point. Like that, here, we can construct a tangent to this curve at the point this. This way. This is a tangent line. We are asked to find, people, its equation. Right. Now, the gradient of this tangent line, if we know, we can very clearly find the equation of tangent line by using the equation today. We learned this y minus y naught equals gradient times x minus x naught. Understood? As our x naught, y naught, people, we can use this 1 and 6. Because x naught, y naught means what? Any point on the line, no? This 1, 6 point is on this curve as well as on this tangent. Because this tangent is constructed to the curve at the point 1, 6. So therefore, this point 1, 6 lies on the curve as well as on the tangent line. There, to use this equation, the gradient of this line we need. People, gradient mean dy by dx. Gradient of this tangent is the dy by dx, first derivative of y with respect to x at this point. To find that gradient, now we can differentiate this. Find dy by dx. In that dy by dx function, since we need the gradient at x equals 1, for every x on the right hand side, we have to put 1. Then we get the gradient. Understand? Okay. So then we can write, people, this like this. Y equals x squared plus 6x minus 1. We differentiate this. Differentiating with respect to x. dy by dx. You know the derivative of x squared is 2x. Derivative of 6x is 6. See here, you get this derivative function in terms of x. Now we need the derivative at the point with x coordinate 1. Then we write that like this, dy by dx at x equals 1 here like this. Put that one here. 2 multiplied by 1 plus 6. This is 8. Gradient is 8. Now we know the gradient is m, and we know x naught, y naught, the point on the tangent line, 1, 6. 1 is x naught, 6 is y naught. Then you can use that equation and you can find the equation of this tangent. Then you can write, therefore, the equation of the tangent. Therefore, the equation of the tangent. Y minus y naught. Y naught is 6. Gradient 8. X minus x naught is 1. This we get. Now take in all the terms left hand side. You can take the equation of the tangent. Y minus 6 equals 8x minus 8 brings this side. Y minus 8x brings this side 8 plus 8 minus 6 is 2. Right hand side it is 0. This is the equation of the tangent line. Right now. Right now, secondly, asking perpendicular line. Perpendicular line means people at the point 1, 6, perpendicular of this tangent, we can draw another line like this here. This here. Here 90. The equation of this perpendicular line also, people, we can find by using this one. There again, the same x naught, y naught we can use because this perpendicular also passing through the point 1, 6. X naught is 1, y naught is 6. Its gradient we need. Now to find the gradient, people, I can use the result I told you. The gradient of this tangent we found, people, as 8 here. Can you remember? I told you if two lines are perpendicular and if you know the gradient of any of them, how to find the gradient of the other? I told you the non-gradient takes the reciprocal and multiply by minus sign. 8 means really 8 by 1. Reciprocal means 1 upon 8 multiplied by minus sign. Then we get the gradient of this minus 1 upon 8. Now x naught, y naught, 1 and 6, gradient minus 1 of 8. Now you can find the equation of what? Using this, the perpendicular, equation of the perpendicular. Understood? All right. Now we'll come to this. Draw that one. Get the gradient in the way I explained. Using that, you can find the equation of the perpendicular. Right? Take that, people. Right. Equation of the perpendicular. What is that? Y minus y naught is 6. Gradient is minus 1 upon 8. X minus 1. Right. Multiply both sides by 8. Here 8y minus 48. We multiply by 8 to evaluate this, eliminate this 8 here, right? Then we get minus, when I write here 8, 8 and 8 we can cancel down. Then we have minus sign, remove the bracket. Minus x plus 1. Bring this to this side. 8y plus x. This one when you bring to this side, minus 1 with minus 48, minus 49 coming. This is how we use those known theories to find the equations, right? People, not this kind of question, right? Little bit complicated question. Usually we can see in past papers, right? Yeah, we'll come to another question, people. Right. Have you finished this one? Right, people. I have made a mistake. What is that mistake? I found the gradient at x equals 1, no? But question gives at x equals 2. I found but at 1. Correct this 1 at the point x equals 2, no? Put that as 1. I gave different one, but worked out different one, no? Yeah. So it is asked x equals 1, no, for this question. Why we use x equals 2? X equals 1, no? I worked out everything for x equals 1, no? The question gives us at x equals, at the point x equals 2. Change this to 1. Then completely everything we can change. X equals 1. Correct that question as at x equals 1. At x equals 1, right? Okay. Right now? Okay. We'll come to another one question. Yeah. Try to write this question. Write down the equation of a curve is given by x equals a sine cube t and y equals b cos cube t. Y equals b cos cube t. Find the equation. Find the equation. Find the equation of the tangent. Find the equation of the tangent Find the equation of the tangent. Drawn to the curve when t equals pi by 4. When t equals pi by 4. When t equals pi by 4. Right. When t equals pi by 4. Right. People, now this time, see the way of giving this equation. X given as a function of t, y given now as a function of t. That t is the third variable. That is called as a parameter. Then this time the x and y coordinates of the curve are given by parametric form using a parameter t. Understand? Okay, not the direct relationship between x and y we have as the equation of the curve. Right? Never mind. Now here also we can draw the graph of this corresponding equation on the xy Cartesian coordinate plane. We can draw, right, people? But we are not going to draw the correct graph, the exact graph. That is not anyway important to work out this question. But remember, we can draw, right? So in our syllabus, drawing this curves of the parametric functions is not available. But in the application of derivative part in the future, we draw the graphs of given equations. That's our another application. In that also, this one we don't consider parametric case. The other case we consider. Right, now suppose people, after drawing this graph on the OXY Cartesian coordinate plane, suppose we get the graph like this, right? People, on this graph, if we consider any point, that point has two coordinates x and y, no? Then that x coordinate is given by this, a sine cube theta. The y coordinate is given by this, y b cos cube t. Understand? That's the meaning. Now, when t equals pi by 4, when t equals pi by 4, we have to find out what are the x and y coordinates of the curve. Put that pi by 4 where? Here. To find what x value. Pi by 4 here to find the y value. Right? Then x equals a sine cube pi by 4. Right? People, sine cube pi by 4 I can write as sine pi by 4 cube, like this. Sine cube pi by 4 means sine pi by 4 cube. Sine pi by 4 is sine 45 1 over root 2. Right? X equals a 1 over root 2 to the power 3, like this. 1 to the power 3 is 1. Root 2 to the power 3 is 2 root 2. Then we get x as a over 2 root 2. The x coordinate of the point a over 2 root 2. Similarly, you can write y coordinate. Put in that t pi by 4 here. b cos cube pi by 4. Y equals b cos pi by 4 cube here. Y equals b cos pi by 4 is 1 over root 2, that to the power 3. Y equals b divided by 2 root 2. Therefore, the point when t equals pi by 4 is, people, a over 2 root 2 is the x coordinate, b over 2 root 2 is the y coordinate. Suppose that point is here, for example. This is that x coordinate a over 2 root 2, y coordinate b over 2 root 2. This is that point. Corresponding to t equals pi by 4. So therefore, suppose this is that point on the curve corresponding to t equals pi by 4. Right. Now, at this point, we can draw a tangent to the curve like this. It's the equation only people now asking. At this point is corresponding to t equals pi by 4. Right. This point is corresponding to the parameter value t pi by 4. When you put t pi by 4 here and here, we get the coordinates like this. Okay. Now the equation of this tangent we need to find. That equation we can find, people, using this relation y minus y naught equals m times x minus x naught. Here x naught, y naught should be a point on the line. As that point, people, you can take this a over root 2 x coordinate, b over 2 root 2 y coordinate, a over 2 root 2 x coordinate, b over 2 root 2 y coordinate. As of x naught, y naught, you can use here. Now we need the gradient of that. Gradient means dy by dx. Now by differentiating this x and y, you have to find now dy by dx, where at this point corresponding to t equals pi by 4. Now let's see how to find that now. Now we have to use parametric differentiation we learned in the differentiation lesson, right? Then let's see how to differentiate that. X equals a sine cube t. We differentiate this x with respect to t because the right hand side variable is t, dx over dt. Okay, a is a constant. Then how differentiate this sine cube t? Where do we start? First by this power 3. 3 sine subtract 1 square t. Then we have differentiated this cube. Then that should be multiplied by the derivative of sine t. What is that? It is derivative of sine t is cos t. Now y equals b cos cube t. Then we can write there dy by dt. B times first power 3 cos square t. Cos t derivative is minus sine t. Understand? Now we need to find dy by dx. To find this dy by dx, we can use the chain rule. By chain rule, you can write dy by dx is equal to dy by dt multiplied by dt by dx. Okay, right. This chain rule, you know, people. Dy by dx is equal to dy by dt is that minus 3b cos square t sine t multiplied by dt over dx. dt over dx means, people, take reciprocal of this. 1 upon 3a sine square t cos t. Right. Now simplify this furthermore. This 3 and this you can cancel down. Of this cos square t, 1 cos t term you can cancel down with this, and here we get only 1 cos t. Of sine square t, here 1 sine t we can cancel down with this. Now we get dy by dx equals this minus sine b upon a, here cos t divided by sine t. Cos t divided by sine t. Now we need this dy by dx means the gradient, no, people. At what point the gradient we need? at this point. That point xy coordinates we have. But people on the right hand side, no x and y letters, but we have t letters. Then we have to substitute for t corresponding to this point. Corresponding to this point, t value is pi by 4. Therefore, to find the gradient at this point, we have to put for this t what? Pi by 4. Understood? Right? Then we'll write that there. Right. dy by dx we need at t equals pi by 4. It's minus b over a cos pi by 4 divided by sine pi by 4. You know cos pi by 4, 1 over root 2, sine pi by 4, 1 over root 2. This you can cancel down. We get minus b by a. What is this minus b by a? Gradient of this tangent at the point this. Now people, we know the gradient. Gradient is what? Minus b by a. Now we know the gradient and the point on the line. Then using this, you can find the equation of the required tangent line. Understood? Right? So therefore, we can write the equation of the tangent. Therefore, the equation of the tangent. What is that? Y minus y naught b over 2 root 2 equals gradient minus b upon a x minus a over 2 root 2. Now we can simplify this people little bit more to take the equation, right? This is one application of derivative, right? Let's simplify this. We'll simplify this little bit. Shall I erase this? Yeah, now we can multiply people here both sides by the 2 root 2a. 2 root 2 and a we multiply. When you multiply this by 2 root 2a, this will be 2 root 2ay. When you multiply this by people 2 root 2a, the 2 root 2 we multiply will cancel with this. This b should be multiplied by a. Then we get ba. On the right hand side, when I write here 2 root 2a, what happens? Minus sign is there. 2 root 2a when you write b upon a here, x minus a over 2 root 2. Right. This a and this a you can cancel down. Multiply by this bracket. Minus 2 root 2 bx. This minus make plus. This 2 root 2 will cancel with this 2 root 2. Right, people? So what do you get? Minus and this minus make plus. Right? Minus and this minus make plus. 2 root 2 and this 2 root 2 we can cancel down. B and A, when we multiply, we get AB. Right? Here we have 2 root 2 AY minus BA. Now bring all the terms to what? Left hand side. Once you bring all the terms to left hand side, these two terms, this one will be plus 2 root 2 ay minus ba plus 2 root 2 bx minus ab. Now on the right hand side we have 0. This minus ba, this minus ab is minus 2ab. Then here we can write, I write this term first, 2 root 2 bx plus 2 root 2 ay minus 2 ab equals 0. We can cancel down these two. Okay. Then we get people the required equation of the line. Root 2 bx plus root 2 ay minus ab equals 0 is the required equation of the tangent. Is the required equation of the tangent. Right now, yeah, the same more questions we will discuss in paper class, people. We can come to the next application. Right, people, in your tutorial, we can come to the next type of questions involving rate of change. Questions involving rate of change. Okay. Right. Under that, we can take some questions in your tutorial. Right. And after this, write down subheading questions involving rate of change. Write down subheading as questions involving the rate of change. Questions involving the rate of change. Right now, you will now take your tutorial. In your tutorial, take question number 81 in the page number 20. Question number 81. Page number 20. Okay. Now, people read this question. Right. That question is this. Sand is being poured from a pipe at the rate of 8 cubic centimeters per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/4 of the base radius. Height of the cone is always 1/4 of the base, right, radius. Now here, this way, the pipe available, this pipe was sand, right? What is the volume of sand per second it passes? 8 cubic centimeters per second, right? Volume 8 cubic centimeters. 8 cubic centimeters per second. Pause this way, right? Now this sand fall into the ground, forms a cone like this. It is very practical, no? You know, when the sand is poured like this, that sand on the ground forms a cone like this. Right. In this case, this cone is such that if we take this height is this. This is perpendicular, right? If this height is h, people, yeah, base radius 1/4 of, right? No. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/4 of the base radius. Height is 1/4 of the base radius. Height is 1/4 of the base radius. That means when the base radius is 4, height is 1. Like that. Height is 1/4 of the base radius. Then if we take the height as h, what should be the base radius? 4h. This is 4h. This is 4h. That's what it says. People now ask me what? How fast is the height of the sand cone increasing when the height is 6 centimeters? Right. Now, people, what happens here really? Initially, no sand on the ground. Once the pipe begins to pour like this, the sand cone is forming on the ground in the said way. Okay. With the time, people, this height of the sand cone increases. Once the height increases, okay, one occasion the height will come to 6 centimeters. That moment, the height increases with a particular rate. That rate only asking. How fast means that, people? How fast is the height of the sand cone increasing when the height is 6 centimeters? Okay. People, now we can take a simple example for this. Suppose we have a conical vessel. This experience I think you have seen in our daily life. Conical vessel we have like this. Keeping the conical vessel like this, we open a tap to this. The tap pours water with the constant rate. Then you can very clearly see, people, at the early stage, the water level increases rapidly this way. Water level increases rapidly. The water level, the height of the water level increasing rapidly. Initial stage. But with the time, what happens? The water level is going up, that's true, but the rate of going up gradually decreases. What is that? Initial stage, people, in 1 second, water level, suppose, increased by 10 centimeters in the first second. Second, water level increases, but in the during the second, water level increases by 8 centimeters. During the first second, it was 10. During the second, it is by 8. Now the whole height is 18 centimeters. Third second, water level increases, but it increases by 6 centimeters. Now altogether total height 24 centimeters. You can see, people, according to the shape of this, what the container, the vessel, right? As the time elapsing, always water level is increasing, that's true. But the rate of increasing water level, that means in 1 second, the water level increased amount gradually decreases with the time. Like that, people, here also, the height of the sand cone always increasing with the time because sand is coming always. Height is increasing. Once the height comes to 6 centimeters, still at that moment even, height increases. Asking at that moment, at what rate height increases? What do you mean by that? If we measure, right, when the height is 6 centimeters, the rate increasing, right? That one only we need to find. Yeah. Now, I have drawn a diagram like this. Now, this diagram is, people, after starting this process, we allow a time simple t, right? So then after starting time t, only this. Right. Now let's consider, people, the volume of this sand cone as V. Okay. Right. Then people first draw this diagram. And we'll write one sentence like this. Right. Write down. Let's consider. Let's consider the moment. Let's consider the moment. Let's consider the moment. A time simple t. Let's consider the moment. Let's consider the moment. A time simple t. A time simple t. After start. After start. Let the volume of the sand cone let the volume of sand cone at this moment B, B. At this moment B, capital V. And then V equals, people, at this moment volume is V, height I took as h, then the radius is 4h. Here, what is the volume of this sand cone now? Volume of a cone is given by what, people?
1/3 pi r squared h.
Yeah, 1/3 pi base radius perfect squared into height, right? So this formula you have learned. If this is r, this is h, the volume is 1/3 pi r squared h. Using this, you can find the volume. Then volume V is equal to 1/3 pi, 4h is the base radius, 1/3 pi r squared, h is, people, the height. We can furthermore simplify this. Pi divided by 3, 4 squared is 16, h squared come in here with this h cube. Then we get V equals 16 pi by 3 times h cube. Right? Now we differentiate both sides with respect to time t, because volume increases with the time, height also increases with the time. Both the volume and the height are functions of t, time. Therefore, we can differentiate both sides with respect to time t. Okay? Differentiating, this is a short form of writing differentiating, right? Both sides with respect to time t. What do you get? Left hand side we get dv by dt. Your right hand side is 16 pi over 3 is a constant. We'll keep that here. 16 pi over 3 is a constant. This h cube we have differentiate with respect to time t like this. This is how we write that. Right now? Both sides we differentiated with respect to time t. With respect to time t. Right. People, how to differentiate this h cube with respect to time t? People, here, this is in terms of h, but here t. You know, this time we can't differentiate this h cube with respect to t. Then we apply here chain rule. Can remember this kind of question we did. Okay, directly we can take the answer, but that answer also come in by that application of chain rule. I'm going to write dv by dt. 16 pi by 3. This one I write d upon dh. H cube, right? dh by dt. Correct, no? dh will cancel off. dt comes here, then d over dt h cube, the same thing coming. We wrote like that, people. Now, you know, this is in terms of h. We differentiate that with respect to h. Now we can differentiate this. H cube, when you differentiate with respect to h, answer is 3h squared. 3h squared. dv by dt is equal to 16 pi by 3. 3h squared. We'll keep this dh upon dt. This 3 and this 3 you can cancel now. Okay. There we have dv by dt is equal to 16 pi h squared dh by dt. People, what is this dv by dt? dv by dt, v is the volume, no? Rate of change of volume. Rate of change of volume, no? Rate of change of volume means what? In 1 second, increment of volume or decrease of volume. People, now look at this. In 1 second, this pipe pours 8 cubic centimeters of sand. Then during that second, the volume of this cone increases by what? 8 cubic centimeters. In 1 second, during 1 second, the pipe pours people 8 cubic centimeters sand to this cone. Then end of that second, if we measure, we can notice the whole volume of the cone during that second has increased by 8 cubic centimeters. What is that? In 1 second, increment of volume by 8 cubic centimeters mean, people, the rate of change of volume of the sand cone is 8. Understand? So therefore, this dv by dt is 8 equals 16 pi h squared dh upon dt. Right? 8 and this 16 we can cancel down like this. Okay. Now there you can subject dh by dt, taking this 2 pi h squared to the left hand side denominator. After cancelling by 8, this is 1 now. Then what do you get? 1 over 2 pi h squared equals dh by dt. Okay. Then subject this dh by dt. People, what is this dh by dt? Rate of change of height of the sand cone. Why? H means height, no? Rate of change of height of the sand cone. That means in 1 second, increment of the height of the sand cone. That is dh by dt. That only we need to find, right? Then it is 1 upon 2 pi h squared. 2 pi h squared. People asking what? While the height is increasing like this, one occasion the height h comes to 6 centimeters. That instant, at what rate the height is going increasing? That means we need this answer when h is 6 centimeters. That means we need dho over dt at h equals 6 centimeters. This is what we need. Substitute that 6 are here. It is 1 over 2 pi 6 squared. 6 squared is 36 into 2, 72 pi. We get 1 upon 72 pi centimeters per second we get. This is the rate of increase in the height when the height of the sand cone comes to the 6 centimeters. Okay. This is how we take that answer. Right now? Okay, we'll come to another one question, people. Take question number 79, part 2. Question number 79, part 2. Read that. Question number 79, part 2. Take that. Right. Here now, that question. If the volume of an expanding cube is increasing at the rate of 4 cubic centimeters per second, then how fast is the surface area increasing when the volume of the cube is 8 cubic centimeters? Right. Now suppose here we have a cube. Cube means, people, what? All three length, width and height being equal. That is called as the cube. Like this. This case, suppose we have a cube. Length, breadth and height being equal. Right? Suppose x is each. This way. Right? If the volume, this is at t equals t. Right? T equals t means what, people? This thing starts and we allow a time simple t to elapse. Then we get the instant that only we have drawn here. At that moment, we will take the volume as v. Then how to write the volume, people? V equals length, breadth into height. X into x into x. V equals x cube. Right? And we are given, people, the rate increase in the volume dv by dt. dV by dt 4 cubic centimeters per second. Right. Okay. 4 cubic centimeters per second. Right. Asking how fast is the surface area increasing? People, what is surface area? We'll write surface area as A. Surface area A. How many surfaces it has? The bottom, top, 2. This side, 4. Front and back, 2. 6 sides. Yeah, 6 sides. Each side has the area what? X squared. There are 6 such sides, 6x squared. This is the total area. A equals 6x squared. Right. Now, people, we differentiate this. Right? We differentiate this. Differentiating with respect to time t. What do we get? dV by dt equals. We have to differentiate this. How differentiate? d over dt x cube. Then, people, you know the method of differentiating this. I am going to write the answer straight away now, this time. People, in the earlier case, how did we differentiate this? We use the chain rule, no? Write in here dx and multiplying dx by dt like this. Then here what do you get? Differentiating this x cube with respect to x is 3x squared into dx by dt. People, in another case, if we take this away answer, no need to write this one. I'll explain the way of getting this answer. We differentiate this x cube with respect to t, no? Then first differentiate this 3. While we differentiate this 3, we don't consider about this one, no? This is x power 3, no? Then 3x squared is the derivative of this 3 that I wrote. Thereafter, we have to differentiate this, no? X, no? But this time x should be differentiated with respect to t. Derivative of x with respect to tx is dx over dt. That I can write here. Then we can skip this part, this step, and we can directly take that. Then we get here dv by dt. Right? But people, what is dv by dt? 4. That 4 we can substitute where here. Right? Now we can subject this dx by dt, taking this 3x squared where here. Then we get 4 upon 3x squared is equal to dx over dt. Take this as equation number 1. Right? Okay, people? Next one. We need the rate of change of the surface area. Right. Now we come to this. We differentiate this with respect to t. Differentiating with respect to t. dA over dt come in. The 6 is constant. Now we differentiate this x squared with respect to t. We don't write this step here. First differentiate this 2. What is that? 2x. And multiply that by the derivative of x. What is that? dx over dt. Understand? Then here we get 6 into 12x. dA by dt. 12x. dx over dt. People, here we have dx over dt is 4 over 3x squared. Substitute for that dx over dt. 4 over 3x squared. Okay. Now this 1x you can cancel down with this 1x. 3 and this 12 we can cancel out by 3. Here we get 4. dA over dt is equal to 4 and 4, it's 16 divided by x. Say this is number 2. People, now you can see here to find this dA over dt. What is dA over dt? Rate of increase in the surface area. You know, when the volume increases, the surface area also increasing. dA over dt means rate of increase the surface area. But to find that, we need x. Now we have to search what is this x we need. People asking, when the volume of the cube is 8 cubic centimeters only, asking us to find the rate of increase in the surface area. When the volume of the cube is 8 cubic centimeters, this V is 8. When we put that 8 for that V, since V equals 8 cubic centimeters, we get what? V equals x cube. Substitute for this V 8. X cube is 8. When x cube is 8, what is x? X is 2. That means, people, volume of the cube 8 mean side is 2. X is 2. Right. Then that 2 we can put here. Then we get rate of increase in the surface area when the volume of the cube is 8. When the volume of the cube 8 means side is 2. Put that 2 for this x. Now we can write, now by number 2, dA over dt at x equals 2, we can write, people, 16 over 2. This is 8. What is unit, people? Square centimeters per second, right? Square centimeters per second. This is at this rate only the area increasing at that moment, right? This is how we take that answer.